world feels like it's spinning faster than ever, doesn't it?
Uh-huh.
Like technology is hitting us with change at a breakneck pace.
Absolutely.
And if you dive into the actual data, that feeling isn't just a hunch. It's the reality unfolding right now,
Yeah,
especially when we look at artificial intelligence.
it really is. What's happening with AI today isn't merely the next step in a familiar tech cycle. It's something occurring at a scale and speed that, frankly, we haven't encountered before.
Right.
It's weaving its way into everything from how individuals interact with their devices to how colossal enterprises manage operations, and it's even starting to, reshape fundamental global dynamics.
Exactly. And that sense of rapid, pervasive change, that's what this deep dive is all about. We're going to explore the core trends that are driving this acceleration.
Mhm.
We're talking about explosive user growth, the staggering amounts of investment pouring in, the colossal infrastructure being built to support it all,
Yeah, the infrastructure piece is huge.
the very tangible impact it's having across countless different areas of life and work, and even the intense global competition that's unfolding because of it.
We've looked at a stack of information that really paints a vivid picture of this current moment in AI. And one of the clearest takeaways is that AI's growth trajectory is truly unprecedented across multiple fronts simultaneously.
Unprecedented. That feels like the defining word right now. You could even frame it as a sort of equation. AI user growth plus usage growth plus capital expenditure growth equals
Yeah,
something we've just never seen before.
that sums it up pretty well.
Let's zero in on that growth first. How fast is this actually hitting individuals?
Well, the poster child for this on the consumer side is ChatGPT. It's a foundational indicator of just how rapidly adoption can happen.
Right.
From its public launch in November 2022 to April 2025, it rocketed up to 800 million weekly active users.
Wow.
Think about that. That's an eightfold increase in user numbers in just 17 months.
800 million weekly users. In less than 2 years. That scale, that speed, it's genuinely hard to grasp. How does that kind of user ramp compare to, say, the early days of something as fundamental as the internet itself?
The difference is dramatic, almost jarring. The internet took a little over 2 decades, 23 years, to reach 90% penetration across the relevant population at the time.
23 years.
ChatGPT, a single application, reached 90% of its massive current user base in just 3 years.
3 years versus 23.
Yeah. That speed of adoption, that speed of reach for a standalone product, it's historically unmatched. Just completely off the charts.
Wow. So it's not just hitting a large number of people quickly. Those people are actually using it actively. We're seeing data like daily time spent on the ChatGPT mobile app in the USA rising by over 202% over 21 months.
That's right. The engagement is deep.
That's incredible engagement growth on top of user growth. And this isn't something isolated to one region, is it? I mean, it feels global.
That's a really critical point. Unlike earlier technology waves, like the initial rollout of the web or even mobile, which often diffuse regionally over years,
Yeah.
sometimes decades,
Right. Slowly spreading out.
ChatGPT exploded onto the global stage simultaneously. It saw rapid, widespread growth across most regions right from the start.
Yeah.
The adoption curve wasn't limited by geographical boundaries in the way previous tech shifts often were.
It was a global phenomenon from day one.
Pretty much, yeah.
Okay, so individual users are diving in at an unbelievable pace, and they're sticking around and engaging. But what about the people who are actually building the future with this technology, the developers? Are they keeping pace?
The developer ecosystem is expanding just as dramatically, if not faster, in certain segments. If you look at the ecosystem around a leading chip maker whose hardware is foundational for AI, it's a really good proxy for developer activity in this space.
Yeah, makes sense.
They saw their developer base grow sixfold, reaching 6 million developers over just 7 years, from 2018 to 2025.
6 million developers just focused on this tech. That's the absolute leading edge of where AI is being applied, isn't it?
It really is. These are the people building the tools and applications.
What does that growth look like when you break it down further, within that 7-year window?
Well, between 2021 and 2025 alone, so just 4 years, the core developer base grew by 2.4x.
Okay.
Even more telling, the number of AI startups within that ecosystem saw even faster growth, increasing by 3.9x to reach 27,000.
27,000 AI startups just in that one ecosystem.
Right. And the actual applications that are leveraging the specialized hardware needed for AI, like GPUs, they increased by 2.4x to 4,000.
Huh.
This kind of growth across the entire stack, The core developers, the entrepreneurial energy in startups, and the actual deployed applications strongly signals deep and accelerating penetration into the broader tech ecosystem.
It means the foundational tools are available, the talent is actively engaged, and they're finding real-world uses for this hardware. So individuals, developers. What about the established powerhouses, the large traditional enterprises? Are they just talking about AI in boardrooms, or are they truly integrating it into their core operations?
They're definitely moving beyond just talk. It's becoming a central strategic imperative. We're seeing data showing that 50% and rising of S&P 500 companies are explicitly mentioning AI on their earnings calls.
Half of the S&P 500.
In climbing. This isn't just buzzword compliance. It indicates that AI is moving up the priority list to become a top strategic focus for the largest corporations.
And when these big companies prioritize AI, what are their main goals? Is it simply about efficiency and cutting costs, which is often the first thought with automation?
While cost reduction is certainly a factor, a global enterprise survey indicates that the primary objectives for AI adoption are actually focused on growth and revenue generation.
Ah, interesting. So growth first.
Seems like it. Things like boosting employee productivity. Think using tools akin to Copilot, integrated into everyday workflows.
Right, like the assistants we're starting to see everywhere.
Exactly. Saving costs associated with highly specialized workers in areas like contact centers or finance, developing customer-facing applications designed to drive revenue or improve satisfaction, accelerating product development cycles, and enhancing risk reduction capabilities. Growth and driving the top line seem to be leading the charge.
That's an important distinction, not just cutting costs, but using AI to grow and build new capabilities. Let's look at some specific examples of how large, established organizations are doing this. Duolingo, the language learning platform, is a fascinating case.
Yes, their CEO has been quite vocal, stating that the company is going to be AI first. They're not just dabbling, they're fundamentally reorienting.
AI first, okay.
A fantastic example is how they used AI for content creation. They developed an entire chess curriculum using AI with a team where reportedly neither person knew how to program or play chess traditionally.
Seriously. No programmers or chess players needed.
That's the report. They're also embedding AI into internal processes like hiring and performance reviews. Their stated approach emphasizes urgency over striving for absolute unattainable perfection from day one,
Right.
highlighting the need to move fast.
Urgency over perfection. That really echoes the speed of change we started with. What about something on the scale of a major financial institution, like JP Morgan? How are they using it?
JP Morgan is undergoing what they describe as an end-to-end AI modernization effort across their vast operations. They see themselves as early movers, but emphasize they're still in the early stages of what's possible.
Still early days, even for them.
Yeah, they're estimating significant value gains ranging from 35% to 65% between 2023 and 2025, specifically from these AI initiatives.
That's a huge potential value gain.
And their CFO has noted that certain key user groups within the bank are gaining several hours a week of productivity by offloading less valuable, more mundane tasks to AI.
Several hours a week of productivity for employees within a giant bank. That's a really tangible impact on daily work. You can feel that.
Absolutely.
What about an industry that might seem less obviously digital, like the fast food sector?
Yum.
Yeah.
Brands, the parent company of giants like KFC, Taco Bell, and Pizza Hut, is leveraging AI through their Byte platform to optimize store operations.
In the restaurants themselves.
Right there. This system uses machine learning to handle things like inventory management, staff scheduling, and even providing real-time food preparation alerts. It's designed to improve decision-making right there in the restaurant and boost staff productivity. So AI is showing up in very physical, customer-facing environments.
So it's penetrating complex financial services, optimizing efficiency in fast food, transforming education and development tools. It's clearly extending far beyond just the traditional tech hubs. What about adoption in government, education, or research institutions? Are they following suit?
Absolutely. AI is a rising priority in those sectors too, often with significant strategic implications. We're seeing an increasing number of nations adopting what are being called sovereign AI policies.
Sovereign AI, what does that entail?
This often involves countries partnering with major infrastructure providers to build their own domestic AI capabilities.
Yeah.
It's being framed quite explicitly like nations making fundamental investments in essential infrastructure,
Oh.
much like they did historically with building national electricity grids or rolling out nationwide internet access.
That comparison investing in AI like electricity is quite powerful. It suggests a fundamental shift in how governments view this technology.
It really does.
And in critical fields like healthcare, AI is getting integrated rapidly, too.
Definitely. There's been a steep increase in FDA-approved AI medical devices. From just a handful in the late 90s, that number has grown to over 220 by 2023.
Wow, quite a jump.
And government R&D funding is reflecting this focus, particularly in healthcare, with the U.S. National Institutes of Health, for instance, requesting 34% of the total FY25 U.S. federal AI budget.
A third of the budget just for health AI.
That allocation shows a clear prioritization of AI's potential in medicine and health.
And drug discovery is one of the areas where AI seems poised to have a transformative impact on timelines, right?
AI-driven drug discovery is showing remarkable acceleration. Companies utilizing these techniques are reporting significant reductions in medical R&D timelines, anywhere from 30% to 80% faster, according to reports from companies like Insilico Medicine and Cradle.
30 to 80% faster.
Imagine the implications for patients and public health if new treatments can be discovered and brought to market in a fraction of the traditional time. It's a direct link between AI advancement and potentially massive societal benefit.
Okay, so the sheer scale and speed of AI adoption and growth across consumers, developers, enterprises, and even governments and research is clearly unprecedented. But all this activity requires a tremendous engine underneath it. What does the underlying infrastructure look like, and what are the economic realities driving it?
That's the next crucial layer to explore. And the underlying dynamic here can be summarized a bit like this. While AI model compute costs for training are high and rising.
Right, the big upfront cost.
The inference cost, the cost of using a trained model to get a result, are falling rapidly.
Okay.
This combination means performance is converging across models, which in turn fuels rising developer usage.
That does sound a bit counterintuitive initially. The core costs are high, but using it gets cheaper, and that leads to more usage. How does that work?
It's about where the major capital is being deployed and how efficiency gains are distributed. Let's start with the foundational investment, the capital expenditure, or CapEx. Big technology companies have seen a dramatic increase in their CapEx with the rise of AI.
Dramatic.
Looking at the big six tech companies, their collective CapEx grew by a staggering 63% year over year in 2024, reaching $212 billion.
$212 billion in 1 year. A 63% increase. That's not marginal growth. That's a massive step change.
It's huge.
How does that level of investment fit into the historical patterns of tech infrastructure spending?
We've seen distinct historical waves of tech CapEx. Initially, with the early internet, it was heavily focused on storage and providing access.
Cables, servers, that kind of thing.
Exactly. Then, with the rise of cloud computing, the focus shifted to distribution and scale building vast networks of data centers. Now, with AI, the investment is primarily centered around computation and intelligence building infrastructure, specifically designed for high-performance AI workloads.
So different needs.
Totally different needs. This requires not just more servers, but specialized chips like GPUs, TPUs, and other accelerators, along with entirely new cooling technologies like liquid cooling and frontier data center designs built from the ground up for AI.
So it's not just scaling up the old cloud infrastructure. It's fundamentally different requirements driving new types of construction. Microsoft's vice chair captured this well, didn't he? Comparing it to electricity.
He did. He described AI and the massive cloud data centers needed to power it as representing the next stage of industrialization, drawing a direct parallel to the transformative impact of electricity in a previous era.
Wow.
It's being viewed not just as a service, but as a fundamental utility backbone for the future economy.
And these data centers are the physical embodiment of that view and that investment. How quickly are they actually able to build these things? Because they seem enormous.
Data centers are key beneficiaries of this intense AI capex, and global spending on IT company data centers has reached historic highs. To give you a sense of the speed and scale, one large AI data center project spanning 750,000 square feet
Okay, that's massive.
was reportedly constructed in just 122 days.
122 days.
Yeah. Think about that as less than half the typical time it takes to build a single average-sized American house.
For something that size.
The CEO of a leading chip maker called this pace superhuman.
Building a structure the size of over 400 houses in under 4 months. That is genuinely mind-boggling speed and coordination.
It is.
What's the economic model underlying these massive centers? What drives the costs?
Well, the significant capital expenditures are tied up in the cost of acquiring land, building out power infrastructure, purchasing the specialized chips, and installing advanced cooling systems. That's the big upfront CapEx.
Right, the build itself.
The ongoing operating expenses, the OpEx, are heavily dominated by energy costs and maintenance. Revenue is then generated by selling access to that powerful compute, whether through API access or platform fees.
So huge capital costs and massive ongoing energy bills.
Exactly. The scale requires immense upfront capital, and energy costs are a persistent challenge.
And that energy demand brings us to a really critical bottleneck. As one perspective put it succinctly, there is no AI without energy.
That's the bottom line. The sheer computational load of AI is incredibly energy intensive. Data centers already accounted for about 1.5% of global electricity consumption in 2024.
1.5% globally.
And that's growing exceptionally fast, around 12% per year globally since 2017, which is more than 4 times faster than the growth in total global electricity consumption.
4 times faster than overall electricity growth.
Wow. And that consumption isn't evenly distributed, is it? Where is it concentrated?
No, it's quite concentrated. The USA currently leads, accounting for approximately 45% of global data center electricity consumption,
Almost half.
followed by China at 25% and Europe at 15%. Within the USA, nearly half of the current data center capacity is clustered in just 5 regional areas, often in states with favorable power costs or infrastructure.
Okay.
This combination of rapid growth and geographic concentration means that further AI progress is increasingly hitting bottlenecks, not just related to data availability or algorithmic breakthroughs, but critically, on the capacity and strain of the underlying energy grid. So even if the technology itself is getting more efficient, the total demand is outstripping those gains. That sounds very much like Jevons paradox in action.
It is a classic example. Jevons paradox posits that technological advancements that increase the efficiency with which a resource is used often lead to an increase rather than a decrease in the total consumption of that resource.
Right, like more efficient cars leading to more driving.
Exactly. In AI, newer chips are vastly more efficient. One recent chip uses 105,000 times less energy per token generated than a predecessor from 2014.
That's an incredible efficiency gain per unit.
It's staggering.
Sure.
But the total number of tokens being processed globally, the total number of AI queries and tasks being run, is exploding so dramatically that the overall energy demand for data centers continues to climb rapidly despite those efficiency gains.
It's that tech's perpetual AHA cycle again. Declining unit costs and improving performance leading to rapidly rising total usage and adoption.
Precisely. Now let's refine the cost picture by looking at the distinction between training costs and inference costs. Training the very largest, most advanced frontier AI models has seen estimated costs escalate dramatically,
How dramatically?
growing approximately 2,400x over 8 years from 2016 to 2024. Reports suggest models currently in training could require investments potentially exceeding $1 billion just for the compute power needed for training.
$1 billion just to train one model.
Potentially, for the absolute cutting-edge ones. So building these foundational models is immensely, prohibitively expensive for most players.
It absolutely requires massive capital and access to huge compute resources.
It does. However, the cost of using those trained models, the inference cost, the cost of getting a response or generating content, is falling rapidly.
Okay, so training is expensive, using it is getting cheaper.
Much cheaper. A simple comparison used is that the cost of generating a 75-word response from a model like ChatGPT today costs a tiny fraction relative to the launch cost of early computer memory, or even the cost of early electric power, when viewed in relative economic terms.
Ah, okay. So the barrier to create the cutting-edge model is incredibly high, but the barrier to access and use a powerful model's capabilities is plummeting.
Exactly. And that difference is where the explosion in adoption comes from. The falling unit costs for users and developers to access powerful AI models via APIs or services is directly leading to the flourishing of new products, services, and applications, driving that rising adoption we discussed earlier.
It's the tech's perpetual AHA cycle playing out in real time for AI access.
That's it.
And as these AI models become more powerful and the cost to use them falls, how are they performing against each other? Is there one clear leader in terms of capability, or is it getting more competitive?
The performance is converging quite rapidly across the top-tier models. Benchmarks like the LMSYS chatbot arena, which crowdsources human evaluation of different models, show leading models reaching very similar levels of accuracy, helpfulness, and realism.
Huh, so they're getting closer in quality.
Yeah, and we're seeing AI surpass human levels on standardized tests like MMLU, which assesses knowledge and problem solving across 57 academic and professional subjects.
So they're not just getting smarter, they're getting harder to distinguish from human output. Is that fair to say?
Increasingly so. A striking example cited a recent Turing test experiment with GPT 4.5, where human testers incorrectly identify the AI's response as human 87% of the time.
87%, wow.
Beyond text, we're also seeing astonishing progress in increasingly realistic image generation, evident in the rapid evolution of tools like Midjourney,
Yeah, those images are incredible now.
and incredibly natural audio translation and generation capabilities from services like 11 Labs. The quality of output is improving across multiple modalities.
So models are getting better, cheaper to use per unit, and their performance is starting to look quite similar across different providers. How does that environment impact the companies offering these models and the market overall?
This confluence of factors, converging performance and rapidly falling inference costs, particularly when accessed via APIs, is weakening the pricing power of incumbent models and effectively leveling the playing field for developers.
Why pay a premium if something else is just as good and cheaper?
Exactly. Why pay a premium if a competing model offers functionally similar performance at a fraction of the cost? Plus, we're seeing a significant proliferation of capable foundation models being released by many different companies: OpenAI, Meta, Mistral, Anthropic, Google, Microsoft, and a host of others. Developers now have a much wider range of powerful options to choose from.
More competition, comparable performance, falling unit costs, lots of model choices. This sounds like an environment that heavily favors developers building on top of these models.
It absolutely does. As history has shown in previous platform shifts, the ecosystem or platform that can attract the most consistent developer, user, and usage momentum and can effectively scale and improve tends to establish dominance.
Right.
And developers are naturally gravitating towards options that offer high performance, flexibility, and accessible pricing.
Okay, we've discussed the explosive digital growth and the colossal infrastructure powering it. But AI isn't confined to our screens and data centers anymore, is it? It's making a significant move into the physical world.
This is where things get particularly interesting, and I'd argue where we're starting to see some of the most profound real-world impacts. We are truly entering an era of physical agents.
Physical agents, meaning?
Intelligence is being embedded not just in software, but directly into vehicles, manufacturing machines, defense systems, agricultural equipment. AI is moving out into the tangible world around us.
Autonomous vehicles are perhaps the most visible manifestation of this shift towards physical AI.
They are. Self-driving fleets from companies like Waymo and vehicles using systems like Tesla's full self-driving are rapidly transitioning from being ambitious science projects to becoming revenue-generating deployments.
So real businesses now.
Becoming real businesses. Waymo, for instance, achieved a 27% share of rideshare in San Francisco over a 20-month period between August 2023 and April 2025.
27% market share in SF in under 2 years.
That's a remarkable level of market penetration for a completely autonomous service in a major, complex urban environment.
That is remarkable. And Tesla's FSD has seen an equally dramatic increase in the amount of real-world data it's collecting through miles driven.
There's been a nearly 100-fold increase in cumulative miles driven by vehicles using Tesla's FSD system over 33 months, from June 2022 to March 2025. That scale of data collection and real-world testing is unprecedented.
100 times more miles.
Yeah. Elon Musk has spoken about a complete architectural rewrite for FSD version 12, shifting from relying on hundreds of thousands of lines of traditional hand-coded C+ logic
Yield weight.
for things like path planning and vehicle controls to an end-to-end AI system built on neural networks. He's called Tesla potentially the most efficient company in the world for AI inference out of sheer necessity, because the AI is running on relatively constrained hardware within the vehicle.
Replacing traditional explicit code with neural networks that learn the task end to end. That sounds like a fundamental shift in how complex physical systems are engineered.
It really is.
And companies are building the tools to enable this shift across various industries, right? Not just cars.
That's right. Companies like Applied Intuition are developing sophisticated simulation platforms and vehicle intelligence systems that aim to abstract away the complexity of building autonomy from scratch for specific hardware.
So making it easier for others to build autonomous things.
Essentially, yes. They serve a range of heavy industries: automotive, trucking, construction, and notably defense. Their leadership talks about bringing the best of Silicon Valley AI methodologies and tooling to global customers in these traditional sectors, and highlighting the strong ROI they're seeing, particularly for traditional OEMs and the defense sector.
Enabling them to adopt this technology faster and more effectively.
Exactly.
Beyond vehicles, AI is also transforming capabilities in defense systems.
Companies like Endural are at the forefront of redefining defense capabilities with AI-enabled autonomous systems. They build everything from autonomous drones for surveillance and interdiction to counter-intrusion systems with AI processing happening right at the edge.
At the edge, meaning on the device itself.
Right, away from centralized data centers. They've reported doubling their revenue year over year for the last 2 years, indicating rapid adoption. Their perspective is that these AI systems can significantly enhance the safety of service members by handling dangerous tasks autonomously.
Makes sense.
And contribute to making warfare more proportional and precise by improving targeting and reducing collateral damage.
Using AI for precision in defense systems. What about applying AI to even more grounded, traditional physical industries like agriculture? That seems like a big leap.
Carbon Robotics has developed machines that use AI computer vision for what they call laser weeding.
Laser weeding.
Yeah, these robots precisely identify weeds in a field and then eliminate them using high-powered lasers, completely removing the need for chemical herbicides.
Wow, no more herbicides.
Their CEO has discussed how this technology directly addresses persistent labor challenges in agriculture and offers the potential for operations to run 24/7. They've already weeded over 230,000 cumulative acres and prevented the use of over 100,000 gallons of glyphosate.
That shows tangible environmental and economic benefits right there.
Definitely.
Laser weeding powered by AI computer vision, that's a perfect concrete example of AI solving a very specific, dirty, and difficult physical world problem. What about resource exploration, like mining? How does AI fit in there?
Cobalt Metals is applying AI they've dubbed Machine Prospector. This AI system is designed to combine vast and diverse data sets, geological, geophysical, satellite imagery, market data, to identify the most promising mineral exploration prospects.
Sifting through all that data to find the best spots.
Exactly. The goal is to accelerate the discovery process and significantly increase the discovery rate compared to the industry average, which has seen declining discovery rates per $1 billion spent.
So making exploration more efficient.
Their CEO believes AI has the potential to fundamentally transform the mining and discovery process, making it much more efficient and potentially unlocking access to critical resources faster.
These examples really drive home that AI isn't just living in our apps or cloud services, it's becoming embedded intelligence in the physical world around us, tackling challenges in transportation, defense, agriculture, and even finding the materials we need. Now, how is this pervasive technology impacting something as fundamental as how we work?
AI is initiating a profound evolution in the nature of work itself. We're seeing a significant shift from purely physical automation, which has been a trend for decades with industrial robots.
Robots on assembly lines, etc.
Right, to what we're calling cognitive automation. This is where AI systems can engage in tasks that require reasoning, creativity, problem-solving, and complex decision-making tasks previously exclusive to human intellect.
Cognitive automation, taking on thinking tasks, and how quickly are AI's cognitive abilities actually improving?
The pace of improvement in AI's cognitive capacity, its ability to understand, reason, and generate complex responses, is incredibly rapid. One analogy used is that just 3 years ago, the capabilities might have been comparable to a bright high school student.
Oh.
Projections suggest that based on the current trajectory, it could reach a level comparable to a college student in the near future. That rate of progress in cognitive tasks is unprecedented.
That pace of cognitive improvement inevitably brings up questions and often anxieties about the impact on jobs.
It's a natural concern, and the labor market data already shows a shift. If you look at IT job postings in the USA, AI-related job postings increased by a staggering 448% over the 7 years, from January 2018 to April 2025.
448% increase in AI jobs.
While over that same period, non-AI IT job postings decreased by 9%.
Down 9%.
This isn't just a subtle change. It's a dramatic reallocation of demand in the labor market towards AI-related skills and roles.
That is a huge shift in demand within just 7 years. But historically, labor productivity gains in the U.S. economy have happened alongside overall job growth over the long term, right? We've seen automation before.
That's correct. Looking back over the past 77 years, since 1947, U.S. non-farm employment and labor productivity have historically trended upwards together. The big question for economists and workers alike is how this current AI wave, which is driving cognitive automation, will align with or potentially disrupt that long-term historical pattern.
Yeah, is this time different?
Business leaders are grappling with this and issuing strong calls for adaptation.
Like the internal memo from the Shopify CEO that got a lot of attention.
That memo was quite direct and widely shared because of its urgency. He stated plainly that AI is fundamentally changing how work gets done right now.
Not in the future, but now.
Now. He warned employees that stagnation is a form of slow-motion failure in this new environment, and that they need to actively embrace and use AI tools in their specific crafts, or they risk being left behind as workflows evolve.
Stagnation is slow motion failure. That's a powerful call to action for individuals within a company. And the CEO of a leading chip maker, Jensen Huang, offered a widely quoted perspective on this. He didn't frame it as AI taking jobs directly.
Right. He framed it not as people losing their jobs to an AI, but rather losing their jobs to somebody who uses AI.
That's a key distinction.
He posits that AI represents potentially the greatest opportunity to close the technology divide because, in his view, almost anyone can effectively program in AI by using natural language prompts rather than needing deep coding expertise.
Making it more accessible.
He connects this to the existing shortage of workers globally and argues that AI has the potential to bring 30 to 40 million workers back into the workforce by augmenting their capabilities, making it potentially the best way to increase global GDP. His message is clear and urgent. Individuals should not ignore this technology.
That really reframes the conversation. It's about leveraging AI as a tool for augmentation to become more capable and productive, rather than simply fearing replacement. And we're seeing early evidence of these productivity gains in various fields.
Yes, studies are beginning to quantify these impacts. One study found a 14% productivity increase among customer support agents using AI tools.
14%, okay.
And another showed an impressive 31% increase for scientists utilizing AI in their research workflows.
31% for scientists, that's significant.
These are early data points, but they provide tangible evidence of AI's potential to significantly boost individual and team productivity.
And corporations are clearly making the pursuit of these productivity gains a central part of their AI strategy, as we discussed.
Revisiting those enterprise objectives we mentioned earlier, productivity enhancements are consistently high on the list, right alongside revenue growth. Data from Q1 2025 shows that about 7% of U.S. firms were already using AI in the actual production of their goods or services.
7% using it in production.
And importantly, that number was up a significant 21% quarter-over-quarter.
Up 21% in just one quarter.
This indicates that adoption is accelerating rapidly and moving beyond pilot projects into core business operations, driven by these goals of increasing productivity and revenue.
So AI is accelerating growth, demanding massive infrastructure, moving into the physical world, and fundamentally reshaping how we work. How is it changing something as foundational as how we access and interact with knowledge and information itself? This feels like another huge area.
This is the knowledge revolution aspect of AI, and the headline here is that the global internet user ramp we're seeing now, fueled by AI from the get-go, represents a growth scale and speed we simply haven't seen before.
Let's put that in historical context by thinking about the evolution of knowledge distribution. How did we get here?
You can trace a clear lineage. We had the printing press, which enabled the static physical distribution of knowledge, a mode that dominated for roughly 6 centuries.
Books, newspapers.
Right. Then came the internet, which ushered in active digital distribution, a mode that has been dominant for about 3 decades.
Search engines, websites.
And now, with generative AI starting prominently around 2022, we have active, digital, and generative distribution. The generative piece is key. AI doesn't just help you find existing information. It can create new information, synthesize, summarize, and present it in novel ways.
Okay.
Fundamentally changing the interface with knowledge.
And the public launch of ChatGPT in November 2022 is often cited as AI's kind of iPhone moment, the point where it hit mass awareness and adoption almost overnight.
It absolutely was. It reached 1 million users in just 5 days, which is the fastest user ramp ever recorded for a standalone consumer product.
5 days to 1 million users.
That speed signaled that this new mode of interaction with technology resonated instantly with a massive global audience.
And critically, the internet is still expanding globally. There are billions of people who are not yet online. How might AI influence their very first experience with digital information?
This is a profound possibility. There are still about 2.6 billion people globally who are not yet online, representing roughly 32% of the world's population.
Almost a third of the world.
Many of these individuals may come online and experience an AI-first internet. Their initial interaction point might not be navigating a complex browser and using a traditional search bar. It could be a simple conversational interface powered by an AI agent
Just talking to.
that understands their language, context, and needs from the start.
And technologies are emerging that are specifically designed to bring connectivity to previously inaccessible areas, like satellite internet from companies like Starlink. That plays into this.
Yes, Starlink has seen incredibly rapid subscriber growth, increasing over 202% annually over the last 3.2 years to reach over 5 million subscribers.
Wow. Huge growth there, too.
Its global coverage is rapidly expanding, enabling internet access in places where traditional infrastructure was impossible, or too expensive remote monitoring in Mexico, providing connectivity for global shipping fleets, bringing rural areas online. This new connectivity can serve as the on-ramp for potentially billions of new users,
Right.
many of whom might encounter AI as their initial digital guide.
So these new users could potentially start with an AI agent that manages their interaction with the internet from a single place, understanding their local language, cultural context, and specific intent, rather than navigating a fragmented landscape of apps and websites.
Exactly. This potential for an agent-first experience could completely upend existing technology hierarchies.
How so?
If an AI agent can effectively manage tasks across multiple platforms from a single conversational interface, booking travel, ordering goods, finding information, the value might shift dramatically from owning the specific app to owning the intelligent conversational interface that manages everything.
And the value moves to the agent layer.
Potentially. It means the interface layer of the internet is being fundamentally rewritten by AI.
And we're already seeing the emergence of these AI agents as a distinct new class of AI capability, not just chatbots.
They're evolving rapidly. The first wave of chatbots was relatively simple and reactive. These new AI agents are designed to be intelligent, persistent, and capable of carrying out multi-step processes that can actually do work autonomously.
Okay, doing work.
Interest in this concept is exploding. Google searches for AI agent increased by over 1,088% over just 16 months.
Huge spike in interest. And the major AI companies and tech incumbents are all rushing to launch their own agent capabilities, aren't they?
Yes, we're seeing announcements and rollouts like OpenAI Operator, Salesforce Agentforce, Anthropic Cloud Computer Use, and Amazon Nova Act. Their capabilities are extending rapidly automated customer support, performing tasks by controlling a computer screen, managing home automation, scheduling appointments, pulling complex information.
Right.
It underscores that this fundamental rewriting of the interface layer by AI agents is happening in real time.
It's like the digital world is getting a new operating system, one based on conversation and intelligent automation. This rapid evolution and the potential it unlocks must be fueling incredibly intense competition across the industry.
Absolutely. The environment is fiercely competitive, and the headline driving the market dynamics right now is something like, AI monetization threats are shaped by rising competition, open source momentum, and China's rapid rise.
Okay, let's break that down. First, talk about the sheer volume of competition in developing these core AI models. How crowded is it?
The pace of new, large-scale AI model releases is astounding. Looking at different modalities, multimodal models, combining text, image, audio, etc., increased by 1,150% over 2 years.
1,100%.
Language models were up 420% over 2 years. Speech and audio models increased by 367% year over year. We're seeing a constant stream of powerful new models being released. GPT-4o, Claude 3, Llama 3, DeepSeek, Qwen 2.5, Ernie 4.5 Turbo, and many others. It's nonstop.
It feels like every week there are major announcements about new model capabilities, new benchmarks being broken.
It's incredibly fast-paced. To give you a sense, the week of May 19th, 2025 wasn't dominated by just one company's announcement. It saw many different companies announcing new models, new features, new subscription tiers. The rate of innovation and deployment is relentless, with companies constantly trying to leapfrog each other.
And alongside the development of these proprietary closed-source models from the big names, there's significant momentum building behind open-source alternatives, right? How does that fit in?
This is a crucial dynamic. Open-source models like Meta's Llama, DeepSeek, and Mistral are rapidly closing the performance gap with the leading closed-source models.
Getting just as good.
Getting very close, often. And crucially, they often offer comparable performance at a fraction of the cost for developers to run.
Ah, the cost factor again.
For developers, this is incredibly appealing because of the raw capability, the ability to customize and fine-tune models for specific needs, and the cost efficiency compared to paying per token for proprietary models.
And developers are, as we've discussed, the leading edge of where this technology gets built into applications. They're the ones choosing the tools.
Exactly. Meta CEO Mark Zuckerberg has publicly predicted that open source models will become the largest type of model developers use in 2025.
That's a bold prediction.
The adoption numbers support this momentum. Meta's Llama has seen over 1 billion downloads by early 2025, leading to the creation of over 100,000 derivative models built off Llama alone. The scale of open source activity represents a powerful force challenging the traditional proprietary software model in AI.
Okay, so intense competition between proprietary models and a huge surge in powerful open source options. This intense competition isn't confined to the commercial realm. It has very significant geopolitical dimensions. How is that playing out?
It's being framed by leaders in the field, like Meta CTO and OpenAI CEO, as a technological space race, with geopolitical stakes that could potentially reshape the world order.
A new space race.
Governments recognize that leadership in AI translates to economic, military, and cultural power. China, in particular, has accelerated its capabilities significantly since the introduction of its Made in China 2025 initiative, which prioritized strategic technologies.
And where has China focused its efforts within this AI push? What are the key areas?
They've focused on accelerating capabilities across key strategic areas, including robotics, electrification, and information technology, with AI underpinning much of this. Chinese AI advancements are now being integrated into critical sectors like military logistics, sophisticated cyber operations, and platforms enabling autonomous decision-making.
So deep integration into strategic sectors.
Right. Chinese state media has highlighted AI integration in military hospitals, and the Ministry of Science and Technology has reinforced the commitment to indigenous innovation in core AI capabilities.
And their progress in developing large language models specifically is quite notable, isn't it? They're catching up fast.
Very notable. Reports indicate that Alibaba's Qwen 2.5 Max model has surpassed some leading Western models on certain reasoning tests. Baidu's Ernie 4.5 Turbo is not only multimodal, but is also significantly cheaper than its competitors,
Cheaper again.
matching or outperforming some Western models on various benchmarks. The cost differential is particularly striking apart. Baidu's model is priced at around 40% of the cost of DeepSeek v3 and an astonishing 0.2% of the price per token of GPT 4.5.
0.2%. That kind of cost advantage is immense and presents a serious competitive challenge globally.
It really does.
And China also holds a leading position in physical automation, particularly industrial robotics. Does that tie in?
Yes, China's installed base of industrial robots was higher than the rest of the world combined in 2023. This indicates a strong existing capability in integrating automation into physical processes, which is increasingly synergistic with advancements in AI.
It also seems there's a difference in public and perhaps philosophical perception of AI between countries like China and the US. How does the general population view it?
A global survey highlighted this. It found that 77% of Chinese respondents believe AI services have more benefits than drawbacks,
Over 3/4 are positive.
compared to only 39% of U.S. respondents.
Less than 40% in the US. That's a big difference.
It points to a potentially deeper societal and cultural divide in how AI is being adapted and perceived, which influence policy and adoption rates.
The U.S. has implemented measures to protect its technology and intellectual property, like export controls. But is it effective? Is U.S. IP still at risk?
There have been tariffs and export controls aimed at restricting access to advanced chips and technology. However, concerns remain that American IP is still at risk, with reports noting efforts by competitors to distill capabilities from leading U.S. AI companies.
Distill meaning copy or replicate.
Essentially trying to train their models based on the outputs of leading U.S. models. Microsoft's Brad Smith has emphasized that the race for international influence in AI will be won by the fastest first mover, and stressed the need for a strong U.S. national strategy to support American AI development and deployment globally.
So, a real sense of urgency on the national level. Given the rapid pace, the intense competition from both proprietary and open source models, and the geopolitical race, how are companies actually making money from AI right now? What do the emerging monetization models look like? Because the investment is huge, but is the revenue there yet?
The economics of AI are still very much evolving. It's a landscape characterized by incredibly high capital intensity for infrastructure and a fierce race to capture and serve exploding user and developer demand. Profitability in the long term is a key question looming over the industry.
The billion-dollar question, maybe literally.
Perhaps, but early monetization avenues are definitely emerging and showing rapid growth.
Okay, what are some of those initial paths to revenue?
One clear path is through API access and generative search services. Anthropic, for instance, has seen incredibly rapid annualized revenue growth, scaling to an estimated $2 billion run rate in just 18 months by selling access to its models via APIs.
2 billion run rate in 18 months, that's fast.
Very fast.
And focusing on enterprise solutions, helping large companies leverage AI on their internal information. Is that working?
Yes. Companies like Glean, which provides enterprise search and AI agents to help large organizations utilize AI on their vast internal knowledge bases, have shown fast ARR, annual run rate growth, going from $10 million to $100 million ARR in just 24 months.
Tenfold growth in 2 years.
There's clear value in unlocking insights from within corporate silos using AI.
It seems like AI companies are growing their revenue faster in their early stages compared to previous generations of software companies, like SaaS.
The data supports that. AI companies are reaching the $5 million annualized revenue milestone approximately 35% faster compared to a benchmark of top-performing SaaS companies from 2018.
35% faster to that first milestone.
It suggests either higher demand, faster product market fit, or perhaps the leverage provided by underlying infrastructure and models.
And the giant tech incumbents have a massive built-in advantage. Billions of existing users they can immediately offer AI capabilities to. That must be a huge monetization engine.
This is perhaps the most significant monetization lever currently. They are seamlessly integrating AI into products used by billions. Microsoft's Copilot has seen 15 billion cumulative chats by the end of 2024.
15 billion chats.
Their estimated annual run rate revenue from AI products reached $13 billion, up a massive 175% year over year.
$13 billion ARR from AI already.
And GitHub Copilot is widely adopted among developers, with 77,000 organizations using it, up 180% year over year, and CIOs increasingly expect to use Microsoft 365 Copilot enterprise-wide.
Meta is similarly pushing its Meta AI across its vast network of social apps, right? How's that going?
They are. Almost 1 billion monthly active users were already using Meta AI across their various apps as of Q1 2025. Mark Zuckerberg has stated his expectation that a highly intelligent, personalized AI assistant will reach over 1 billion people in 2025.
1 billion users for their assistant.
And sees Meta AI positioned to be the leader in that space, leveraging their unparalleled user base.
And Google is integrating AI into its core search and ecosystem with Gemini and AI overviews. What are their numbers looking like?
Google's Gemini app ecosystem reached over 500 million global monthly active users by April 2025. The volume of monthly tokens processed across Google's AI services increased dramatically, up 48x year over year to 480 trillion by May 2025.
48 times more tokens processed just shows the scale of usage.
Exactly, indicating explosive usage. They are also rolling out AI overviews directly into search results to provide AI-augmented answers and information.
We're seeing similar integration and usage numbers on other major platforms too, like Adobe, Atlassian, Zoom.
Absolutely. Adobe's Firefly generative AI features have been used to generate over 16 billion images by May 2025. Atlassian Intelligence reached over 1 million users by December 2024. Zoom AI Companion saw over 1.2 million accounts activated by July 2024, with accelerating quarter-over-quarter growth. Canva had over 16 billion Magic Studio generations by May 2025.
16 billion.
Salesforce's Agentforce, which is part of their rapidly growing data cloud and AI revenue, had 3,000 paying customers within just 90 days of its launch. These show AI being successfully monetized by embedding it directly into established workflows and platforms used by millions or billions.
So embedding it is key for the incumbents. Beyond the tech giants, we're also seeing specialized AI software companies targeting specific large service industries achieve incredible growth. This seems like another important path.
This is another fascinating area of rapid monetization. Companies building AI software tailored for specific verticals are showing explosive ARR growth. In software engineering, AnySphere Cursor AI went from $1 million to $300 million ARR in just 25 months. By providing AI coding assistance?
1 million to 300 million in just over 2 years.
Astonishing growth. In product development, Lovable grew from $4 million to $50 million ARR in a mere 5 months.
5 months to go from 4 to 50 million. That kind of growth velocity for specialized tools is incredible. What about in critical sectors like healthcare and legal services?
In healthcare, Obridge, which uses AI to summarize patient visits, grew from $50 million to $117 million ARR in just 5 months. Kaiser Permanente doctors are using it, and over 10 million visit summaries have been completed, showing deep integration into clinical workflows.
Real impact in hospitals.
In the legal sector, Harvey, which provides AI assistance for legal work, saw its ARR grow from $10 million to $70 million in 15 months and is already adopted by a majority of the top 10 U.S. law firms.
So the top law firms are already using it. And in areas like customer service and financial analysis, similar trends.
Decagon, focused on AI for customer service, grew from $1 million to $10 million ARR in 1 year. AlphaSense, which provides AI-powered search and analysis for financial professionals, grew from around $150 million to approximately $420 million ARR in just 2 years.
Huge numbers.
These examples show that while the underlying AI models are foundational, significant value and rapid revenue growth are being captured by companies building highly specialized AI applications for specific high-value industries.
So specialization is another key monetization strategy. And supporting all this massive investment and the race to build out infrastructure are the large tech companies themselves, which are in a strong financial position to keep funding this.
That's right. The big 6 companies enabling this AI build-out collectively possess significant free cash flow, totaling $443 billion, which is up 103% over the last 10 years.
Nearly $500 billion in cash flow.
This financial strength allows them to fund incredibly high levels of R&D, which now represents 13% of their revenue compared to 9% a decade ago. As well as the colossal CapEx required for AI infrastructure, they have the resources to keep pushing.
Some of the pure-play AI companies have also achieved extremely high valuations relative to their current revenue, reminiscent of previous tech booms, like the dot-com era, maybe.
They do. Companies like OpenAI, Anthropic, xAI, and Perplexity have commanded valuation multiples that are quite high when compared to many established, profitable tech companies. It definitely draws historical parallels to previous periods of intense technological disruption.
Like railways, or maybe early internet stocks.
Exactly. The railway boom, the early days of companies like Apple or Amazon, or the rapid growth phases of Uber and Tesla. In those cases, companies often burned cash aggressively in their early stages to build critical infrastructure, establish network effects, or gain a competitive advantage,
Begging on the future.
ultimately proving the profitability of a new model.
So the big question is, will the current generation of AI aspirants successfully navigate this period of immense investment and intense competition to achieve sustained profitability? Or will the economics prove too challenging? Where will they land?
That is the central question the market is grappling with, and honestly, only time will truly provide the answer. The monetization models are clearly emerging, driven by API access, deep enterprise adoption, leveraging existing massive user bases, and building specialized vertical applications.
Right, we see the paths.
But the upfront costs, particularly for training frontier models and building out infrastructure, are immense, and the competition, including from increasingly capable open-source models and state-backed initiatives, is absolutely relentless. It's a high-stakes game.
We've covered so much ground. The unprecedented speed of growth, the immense infrastructure build-out, AI's move into the physical world, its impact on work and how we access information, the intense global competition driving both innovation and posing challenges, and the emerging monetization paths. What's on the horizon? What are the next frontiers for AI? Where does it go from here?
Beyond the applications that are becoming mainstream now, the next wave of impact will likely include areas like accelerating medical discovery and development, enabling much more precise manufacturing, developing truly multi-purpose robotics capable of complex physical tasks.
Robots that can do many different things.
Potentially, yeah. Automating aspects of scientific research, enhancing cybersecurity defenses, providing highly personalized education, enabling more autonomous financial systems, improving environmental monitoring, and optimizing energy grid management. These are areas where AI is starting to make inroads and where significant future breakthroughs are expected.
That's a huge range of potential impact areas. And what technological capability seems key to unlocking many of these diverse future frontiers? What's the enabling tech?
Multimodal AI seems critical.
Multimodal, meaning?
The ability for AI models to seamlessly integrate and process information from text, images, audio, video, and potentially other data types simultaneously. It's key because the real world isn't just text. It's rich, complex, sensory input.
Right. The world isn't just words on a page.
Multimodality cuts down on the need to translate information between different systems, captures richer contextual detail, and enables entirely new types of applications that require understanding across modalities.
Can you give a couple of quick examples of how multimodal AI might function in these next wave areas? Make it concrete.
Sure. Imagine a field engineer diagnosing complex machinery issues by simply pointing their phone camera at a component and asking the AI assistant a question about it.
Using video input.
Receiving a plain language explanation of a potential fault based on visual input in system manuals. Or a clinician attaching an X-ray image to a patient's note and having the AI automatically draft a structured radiology report.
Combining image and text.
Or a financial analyst asking a query that combines data from charts, conference call transcripts, and video recordings of presentations. These tasks require the AI to understand and interact across multiple types of information intuitively, which is what multimodal AI enables.
Multimodality feels like a necessary step for AI to move beyond the digital interface and interact more naturally and effectively with the complexities of the real physical world. Now, with all this incredible pace of advancement, the immense potential, the economic shifts, and the geopolitical dimensions, we have to talk about the inherent risks that come with such powerful technology. It's not all upside.
No, it's definitely not. The materials acknowledge that these are dangerous and uncertain times. The potential risks that arise from the capabilities we've discussed are significant.
Like what specific?
Based on current trends, these include the proliferation of lethal autonomous weapons, enhanced capabilities for surveillance and persuasion, the potential for biased decision-making embedded in powerful systems.
Yeah, bias is a big concern.
Significant disruption to employment patterns. The challenges of ensuring safety in critical AI applications like autonomous vehicles or medical devices, and the potential for new and more sophisticated cybersecurity threats.
It brings to mind Stephen Hawking's cautionary thought on AI development. He saw both sides.
He famously said that success in creating AI could be the biggest event in the history of our civilization, but it could also be the last unless we learn how to avoid the risks.
Could also be the last. That's sobering.
It's a powerful, if stark, reminder of the incredibly high stakes involved in navigating this transition.
So, given these very real and significant dangers, is there a case for long-term optimism? How do we balance the immense potential for progress and benefit with the profound risks? Is there a path forward?
The case for optimism is often grounded in the very forces driving the progress. Intense competition spurs rapid innovation. Increasingly accessible compute resources foster diverse applications, and rising global adoption means more people are engaging with the technology and its implications.
So the dynamism itself could be a check.
Perhaps. There's also the hope that thoughtful leadership, coupled with what one perspective described as sufficient trepidation and respect for the risks, could lead to something akin to a form of mutually assured deterrence, where the potential downsides are so clear that major actors are cautious about pushing boundaries recklessly.
Deterrence through understanding the risks. It's a complex and delicate balancing act between the forces that feel like a race to the bottom driven by pure speed and competition, and the need for a more cautious race to the top focused on safety and beneficial outcomes.
Exactly. The speculative and frenetic forces of capitalism and creative destruction that are driving so much of the innovation are tectonic, powerful, and moving incredibly fast. But the potential downsides of mismanaging this technology are immense and unprecedented. It requires extremely careful navigation from researchers, developers, policymakers, and frankly, everyone's impacted by this technology, which is rapidly becoming all of us.
So looking back at the entire landscape we've explored today, from the unprecedented speed of AI's adoption and growth to the massive infrastructure being built to power it, its fundamental move into the physical world, the tangible impact it's already having on how we work and access information, the intense global competition shaping the market and the geopolitics, and the exciting but risky frontiers ahead. What's the big takeaway?
It's abundantly clear that AI is rapidly moving towards achieving a pervasive nature in our lives, much like the internet did before it.
Yeah.
It's not just a tool anymore, it's becoming a deeply embedded layer in the fabric of how we live, interact, and operate in the world.
It feels like AI is quickly becoming as fundamental to our daily lives and the global economy as the internet itself is today. It's hard to imagine life without the internet now.
Right, and that leads to a powerful lingering thought, based on the dynamics we've discussed. Soon, imagining a world without AI might feel as impossible and alien as imagining one without the internet feels to us today. And crucially, the ongoing global competition, particularly between major powers like the US and China, is perhaps the single most significant dynamic that will continue to shape the landscape and trajectory of AI development and deployment worldwide. In this era, innovation isn't just a business advantage.
It's more than that.
It is rapidly becoming synonymous